My name is Carlos Mario Calderón, and I am studying at the Fundación Universitaria Los Libertadores. Today, under the guidance of Professor Henry Telles, I will present four fundamental concepts in electricity and electronics: Ohm laws, Coulomb laws, electric potential energy, and electric current. These principles are essential for understanding how electricity works, both in theory and in practical application. Ohm laws. Ohm laws tell us how voltage, current, and resistance relate to each other in an electric circuit. It is expressed with the formula V same I multiply R, where V is the voltage in volts, I is the current in amperes, R is the resistance in ohms. For example, if we apply 9 volts across a resistance of 3 ohms, the current will be current same 9 volts over 3 ohms, same current 3 amperes. A helpful analogy is thinking of voltage as water pressure, current as the water flow under resistance, and as the width of the pipe. These relationships is the basis for understanding how all electric circuit functions, from light bulbs to complex computer systems. Coulomb Labs. Coulomb Labs describes the electrostatic force between two charged particles. The formula is if same K multiply Q1 multiply Q2 over R squared, where F is the electricity force in Newton, Q1 and Q2 are the magnitude of the charges in coulombs, R is the resistance between them in meters, and K is Coulomb constant, approximating 9 between to the 9 Newton for meters squared over coulombs squared. For example, two charges of 1 microcoulomb separated by 10 centimeters experience a repulsive force of about 0.9 newtons. While Ohm's law tells us how current behaves is in a conductor, Coulomb laws help us understand the interaction between individual charges, whether they attract or repel each other. Electric potential energy. Electric potential energy is the energy stored due to the position of the electric charges. For 2-point charges, the electric potential energy is calculated as U same K multiply Q1 multiply Q2 over R. This energy is positive if the charges repel each other and negative if they attract. For example, in a capacitor, we store electrical potential energy when we separate opposite charges. That energy can be released later, like in the camera flash, used as lifting an object increase its gravitational potential energy. Separating electric charges increases their electric potential energy. This concept is key in storing and transforming energy in circuits. Electric current. Electric current is the flow of electric charge through a conductor. It is defined as I sum Q over delta T, where I is the current in amperes, Q is the charge in coulombs, and delta T is the time in seconds. The elementary unit of electric charge is the electron, which carried a charge of electron saying 1.602 exponent to the minus 19 coulombs. If a wire currents a current of 2 amperes, it means that 2 coulombs of charge passes through is every second. That's roughly 1.25 exponent to the 19 electrons moving per second. Electronic current is the result of charge in movements, in motions, and it is made possible by the electric force described by Coulomb's law and governed within material by Ohm laws. In conclusion, Ohm laws help us understanding how voltage and resistance determine current. Coulomb laws explain the force between charges. Electrical potential energy tells us how energy is stored in the position of charges, and the electric current is the movement of the charges through a conductor. This concept for the foundation of everything from simple circuits to complex electronic systems. Understanding them not only helps us design better technology, but as depend or appreciation for how the invisible light world of the electricity powers the visible light one around us. Practical examples. Ohm law example. Calculating resistance in households wearing. Coulomb Labs example. Determining force between charged particles in a sensor, energy and current, measuring power combustions in electric device. Thanks you very much for your attention. That's all for today.